The three main principles of universal design for learning are providing students with multiple means of representation, multiple means of action and expression, and multiple means of engagement. Applying these principles allows teachers to engage all of the learning centers of the brain, thereby maximizing their opportunity for comprehension, retention, evaluation, and application of knowledge gained. Principle 1 of UDL calls for multiple means of representation. This principle addresses the what of learning. This region of the brain is responsible for how we gather and categorize information based on visual, auditory, and tactile input. Appealing to the recognition networks of the brain requires that information and content be presented using a variety of methods. There are three guidelines associated with Principle 1. Providing multiple means of representation. These guidelines include providing options for perception, for language and symbols, and for comprehension. Students cannot learn if they are unable to perceive the information that is being presented. Customizing the display of information and providing alternatives for auditory and/or visual information are examples of ways that you can help your students to better comprehend the information you present.
I'll pass out a handout when I'm introducing a lecture or introducing a lesson. And then after the class is over with, I go through and I'll pick up about half of them, and the students didn't take them with them. They didn't take it with them. This year I started using these posters. It's just blown up, very simple. And I hang it out in the lab where the students are working. When they ask the question, the first answer is almost always, go back and look. Go back and look at that handout and follow the directions. And it makes them read the directions and have to follow written directions. And it prepares them for going to work for an employer who has given them some kind of a job sheet. I need this done, to be able to follow that.
You're thinking of it as...
I'm so confused.
I know, okay, stand up. Stand up. Yes, seriously, stand up. Watch the wires. Okay, look. We're acting like there's the hallway right here, right? Okay, you have the hallway and then you have that long stretch before the next hallway, right? Okay, that's where the science labs are. So it's like the science labs are in the middle of your two hallways, even though you can only enter them on one side or the other. Another UDL practice that I use is making sure that the kids have something hands-on to do, and that's one of the main focuses of a CTE course, is that you're not only showing them what to do, but as you're showing them what to do, they are also doing it. So they're not just sitting there watching you lecture, watching you do something else. They're doing what you're showing them to do to help them learn that skill.
Everybody look up here. Everybody look up here. This bag has been used. It's got kind of a lot of air in it. Okay? Take the top, hold it, and then just twist the whole thing. Okay? And what you're doing is you're twisting your product down towards the bottom. Okay? However, you still have a little bit of air in there. You can kind of pinch it off a little bit and help massage some of that stuff down in there. To hold it, twist it, and then squeeze it out. All right? But make sure you're twisting it at the top and moving that product down.
Providing alternatives or clarification of language and symbols often translates into better student learning. It's necessary to define even commonly used terms or illustrate key concepts both linguistically and non-linguistically.
And I want you to look at the table that you have on your page, and you tell me how many columns we need. How many columns do you see?
4.
4 columns. So we have 4 columns, and how many rows do we need?
3, 4.
Not 3. Try
7.
7. Count all the rows. Remember, your rows go horizontal, left and right. Your columns are vertical, they go up and down. So we need 4 columns and 7 rows.
Cutting attachment attaches. Hand tight, pointed, same direction the valves point. Same way the cutting attachment is. Going to turn our cylinders on. How far I turn this one on?
All the way.
How come? Because it's high pressure. It's got 2 seats in the valve. About this one? Quarter turn. Carburizing or oxidizing. For welding, we're going to use a neutral flame. How do I know it's neutral? Same way we do the cutting torch. The little feather, we're going to bring it back to where it's the same length as that cone. If we bring it too far, we get that. See how it's sharpened up? You hear the difference?
Who knows what this is? And what we use it for? Mix doughs, bread doughs. This is a dough hook, okay? When the dough for breads are ready and prepared properly, it will crawl up this hook, all right? The elasticity of it just kind of pulls it up this hook, and it's set.
You can offer students options for comprehension by invoking background knowledge and highlighting big ideas or relationships.
Come on, there it is. All right. Now I've got it tacked. And once you got it tacked, you just walk that bead along. Just like you're welding, except it's much slower and much quieter. See the bead forming? Looks just like that drawing we did back in the early year, doesn't it?
Your assignment was to convert that recipe to 10 times the original recipe, okay? That's what I'm doing in the kitchen with the cake recipes. In order to make, instead of making the individual cupcakes that we've been making, we're doing big sheet pans because it helps us get out more products so we can play with, we can work with. Well, we've got to convert that. And these are a couple of fractions that we're having to convert. Remember them? What do we do to convert this? 10 times what? 10 times a 2, right? So that's 20. And then 20 divided by 3 is what?
6 2/3.
What? 6 2/3. Yeah. 6 2/3. And that's then what are we working on? One of them is cups, right? I think they're mainly cups that we're working with, and so forth.